Dr. Mahsa Azadmanesh, who will be presenting, well, two short topics. Yes, Dr. Azadmanesh, please, you have the floor.
Hello everyone and welcome to Ilora Conference. So I'm here to talk about space. Space is no longer empty. It's a huge, complicated marketplace. And to actually handle such a huge marketplace, we're going to need future space leaders who understand space law. So I am Dr. Maxwell Azadmanesh. Yes, next. I am Dr. Maxwell Azadmanesh, and I am here on behalf of our research team. The rest of the research team are Dr. Hamide Azimzadeh, Associate Professor Dr. Krasim Georgiev, Associate Professor Dr. Roya Asiai, and Associate Professor Dr. Ivailo Pe. And I am here with a computer game that we developed to prove a point. And that point is, and that point is that traditional lectures fail. Traditional lectures fail so hard that we need a new interactive method, a new interactive approach. So the objective is to teach space law to students from non-law related majors. And that's quite a challenge. And when we do that, students seem to remember some terminologies. They understand and remember some vocab. But when it comes to application, when we want to see if they can make decisions based on what they have learned, they fail. So that's called knowledge decoupling. Knowledge decoupling is when you know the terms, but you can't do anything with them. So we asked ourselves, can a mini game fix this? And the answer is yes. Could you please change it? Thank you so much. So we designed a mini game. We designed a study. I'm going to show you parts of that mini game later. So the duration, the intervention time is in fact 5 minutes. We asked 20 students from non-law related majors to take part in this study. 10 were the control group. The other 10 had fun. They used the game. 1 hour later, we tested them. So the game is called the Starport. First of all, the student is given a scenario, an animation, a very short one. For example, a rocket crashing into something. And then we teach them the word liability. Liability is legal responsibility. And then immediately they're asked a question. What is the scenario? And they choose liability. So they learn the terminology while watching an animation. Okay, I'm gonna show a demo. When we click on start, we see a rover, we see some germs. Now there's a law called planetary protection. We are not allowed to bring microorganisms from Earth to other planets. That's both dangerous and it will actually make our results unreliable. So we're not allowed to bring microorganisms to space. So what we do is, could you please click on the germs? Wait, could you please? No, here. Okay, so when they are clicking on the germs, and they see the word planetary protection, something happens in their memory, and they memorize the vocab while doing something active in the game. Next one. So the results were amazing, actually. In case of terminology recall, the students who only got the lecture scored 3.5, while the game players scored 5.2. The score is out of 6. Next one. But when we actually gave them scenarios, when we ask them, what if this, and that happens? The game group scored 4.9. It means that they could associate those ideas into real life decisions. They could actually use that information. Next one. So the reason traditional lectures fail, we believe that they actually burden the mind. They have a high cognitive load that they pose the students to. And the gamification is actually forcing students to have active retrieval and synthesis. So obviously, this is proof that instructional design is decision design. It means that we need to shape the way the students decide instead of just focusing on the memory. So we're hoping gamification is the future of learning. And we didn't stop there. When we saw that works, we tried it with another subject area, space debris. The orbits are filled with space debris. Space debris is the material, the junk that is remained after a mission is finished. Sometimes they explode, sometimes they're just abandoned there. So the whole orbits are filled with space debris. So what do we do about that? How do we give the students this knowledge that how dangerous that is? So we actually designed another mini game. It's platform-based, and we try to teach them about the Kessler syndrome. Kessler syndrome refers to something very dangerous. When two debris in the orbit collide with each other, tens, hundreds, even thousands, even millions of small pieces are produced. And they themselves make, they are more dangerous than the previous ones because they have very high velocities. And for our students to understand this, they needed something like a game, something that they could actually see what happens. So we tested that. Kessler syndrome refers to a self-sustaining chain reaction of collisions rendering orbits unusable. That's the best way to define it. So why were students having problems understanding these things? We found out that it's conceptual barriers. It means that they learn about energy, half of MV2, but they have no idea what that means when it comes to visualize. Or they understand drag, inclination. These are all aerospace-related terminologies. The same problem that we had before, but they have no idea what these things are. So our micro simulation, our little game, actually helped them understand these terminologies better. So the results were, they showed 71% improvement in remembering and understanding these terminologies, and we also took a test about how certain they feel about what they have learned and how happy they are. Two more questions: how certain do you feel, and how happy you are about what you have learned. Obviously, the ones who had fun were happier and felt more certain about what they have learned. So actually, we saw that simulation trains intuition, not just memory, and all these complex concepts can be taught through this game. And I would like to thank the Funding Institute, and if there are any questions. Thank you so much for listening. Thank you for the opportunity.
And thank you very much for presenting in such a spectacular way and, well, very involving and really insightful. Okay, thank you very much indeed. Now, we're moving on, unless we have any questions or remarks. or comments?
I just may
Yes,
say
please.
something.
Yes.
Right, so I'm impressed by the way this presentation was conducted, but just I would like to make a short remark. In my personal view, you cannot completely reject the so-called traditional teaching, traditional lecturing, and so on. So what matters is to achieve a kind of a balance, kind of equilibrium in terms of thanks, various concepts presentation in the way they are afterwards practiced, exemplified, and well, of course, putting into practice is crucial, is relevant, and the way concepts and different pieces of knowledge are manipulated and processed and retrieved so that you may finally achieve a result which can be seen in terms of knowledge practical implementation. So some kind of a balance needs to be sought. This is my remark. But the presentation was really spectacular and quite interesting and exciting to everyone, I suppose.
Thank you so much. Thank you so much. That's very true. And I just want to point out, we obviously know how a successful lecturing is, but we found out the shortcomings. We found out some weak points, and we try to cover it with gamification. But obviously, we will always need lecturing, but we try to cover the shortcomings so that we can have brilliant lectures in classes, hopefully in the future.
Yes, thank you very much. So obviously making the most of both approaches and combining them in a positive way, in a well, benefiting way would be the solution. Yeah, but striking the balance has always been well the key to success. Yes, thank you very much, Lisa. And now I'm particularly pleased and absolutely delighted to introduce